Um, okay, let's look at the plane once again. And say, okay, so we're just going to draw a line in this plane. There you go. And we want to find the vector equation of a line. Is there such a thing? Well, let's pick a point on this line. Let's call this point A. And then another point here, B. And okay, so here we have the point A. So basically, any point which is on this line would be in the direction of the vector AB, in the direction of the vector AB. And so, so say for example this point M. So the vector OM, so for OM to be part of the line, OM is here. OM, well, OM is made of what? Is made of OA, plus, well, a value, basically AM, it's AM, I'm just going to go, so OM is OA, plus AM is just a multiple of the vector AB, where lambda belongs to R here. This is called the vector equation of a line, of the line. Now for any point for all points belonging to the line, we could find a value of lambda. Let's do an example. Say we have okay, well, let's do that. We have the y-axis, the x-axis, and then we have a line, and say this point here A is I'm just going to do that in 2D, and then it's just it's pretty much exactly the same in 3D. So 1 and then 1, right? So this is point A, and here we are saying that this vector here, well, it is say 2i plus j. It looks pretty right for my drawing. So any point here M, so this line would have for equation x of t would be, you know what, I'm just gonna go a bit slower. I'm gonna say OM, any point that belongs to the line is equal to OA plus AM. So therefore OA is what? It's I plus j. There's this vector here. And then AM, well, AM it's a multiple of the vector 2i plus g, so it's a lambda times 2i plus j, where a lambda belongs to R. And so, okay, OM it's made of an x component, which is x of t plus y of tj. And so, well, what we can say is therefore x of t is equal to 1, because that's a 1, that's a component, plus 2 lambda. And then y of t is equal to 1 plus lambda. And this is the vector equation of the line. Right, that's in 2D. In 3D, let's do an example in 3D. So, say we are given 2 points, P1, which has for coordinate 2, 1, 2, and P2, which has for coordinate -1, 3, and 3. And, okay, we want to find the vector equation of the line passing through P1 and P2. Okay, right, so basically this vector would be OM is equal to OP1 plus P1M. Okay, so that's equal to 2I plus J plus 2K. And then P1M, well, P1M is just lambda times P1, P2. Because basically the 3 points are aligned, so P1, P2, and then M. So basically P1 is just a multiple of the vector, P1M is a multiple of the vector P1, P2. And so it's equal to 2I plus J plus 2K plus lambda times, and P1, P2, it's -1, -2, so that's -3I. 3 minus 1, that's plus 2J. And then 3 minus 2 plus K. So, okay, so grouping the I terms together, so that's 2 minus 3 lambda I plus 1 plus 2 lambda J plus 2 plus lambda K. And this is the vector equation of the line. Now, you may wonder something. You say, oh, why did you pick P1? You could have done the P2 as well. So you could have written OM is equal to OP2 plus P2M. And so in that case, yes, that would be a bit different. That would be OP2. So that would be minus I plus 3J plus 3K plus lambda P2M, well, it's also a multiple of the vector P1, P2. So P1, P2. You know what, instead of using lambda, I'm going to use another value, another letter. I'm going to use mu to show that they are different. And so it's equal to what? Minus the first component doesn't change. Plus mu, and then P1, P2, that doesn't change. 1, 3I plus 2J, well, sorry, mu belong to R as well, like lambda belong to R. Then plus K. Now again, I'm going to group the I terms together, so that's -1 minus 3 mu I plus 3 plus 2 mu J plus 3 plus mu K. And that's also the vector equation of the line. Vector equation of the same line. So it's important here to notice that although this equation is apparently different from the other one. In fact, they are the same. They represent the same line. Okay, so how does it work? Well, if we were going to pick a point M on the line, if we were going to pick this equation, we would need a certain value of lambda, whereas if we're going to pick this equation, we would need another value of mu, but basically they represent both the same line. So all of that to say that the representation of a line is not unique.